Minor details.
I'd be okay with that.
All right, 24. These ones say to find the asymptotes in the intercepts of the function and graph the function. We're doing everything but the graphing part. G of x is equal to x plus 2 divided by x squared plus 2x minus 3. All right, so asymptotes, we already know how to find those. How do I go about finding my vertical asymptote? So x squared plus 2x minus 3 equals 0. Now what? What does it factor into?
X plus 3x minus 1.
So that means x equals?
X equals -3 and x equals 1.
Yep. So my vertical asymptotes are at x equals -3 and x equals 1. Horizontal asymptotes.
Bigger on bottom, 0.
Bigger on bottom, y equals 0.
Good job, Virginia.
All right, now intercepts, this is probably the thing that you've probably done this before, but you don't realize or you don't remember how to do it. So to find an x-intercept, okay, we set y equal to 0. To find x-intercepts, we set x equal to 0. So you would have done this back when we did intercept form of a line. We had it in standard form and we used the cover-up method. That was basically what we did. Now we just are doing this for this entire problem. So basically we're taking this to find the x-intercept and setting x plus 2 divided by x squared plus 2x minus 3 equal to 0. And I'm trying to solve basically for x. Now, does anybody recognize anything? What's going to happen here?
Well, there's like an x plus 2 on the top, and there's an x squared plus 2x on the bottom.
Can't do anything with that. It's all being added.
Could we like...
It's equal to 0, so what does that mean about the denominator?
It's also equal to 0?
Well, no. If I multiply to get rid of this on the bottom, what happens?
It's a cubic function.
No, this cancels. Top and bottom cancels. 0 times that is 0. So that means when I'm finding x-intercepts, what do I care about?
The top.
Only the top. So x plus 2 equals 0, so x equals -2. So that means that I have an x-intercept at the point -2, 0. Okay, intercepts are points, asymptotes are lines. So when you have a problem like this and I want the intercepts, okay, if I want the x-intercept, I only care about the top. Because the bottom is going to go away when I set it equal to 0.
That makes
In
sense
every
now.
situation.
I was gonna say, that was rough trying to get through this.
Okay, the y-intercept, just do this over here. We set x equal to 0. So every x that we have up here is going to be equal to 0. So we've got y is equal to 0 plus 2 divided by 0 plus 2 times 0 minus 3. So y is equal to -2/3. So my y-intercept is at the point 0 and -2/3.
That makes a lot of sense. It's a lot easier than what we thought it was. That's what I thought it was. Not sure about that.
All right, so normally I just do one of these because you already know how to do the asymptotes. It's only the intercept part that's new. Do you need to see another one, or are you okay with that? I mean, because in a sense we've done intercepts before. It's just never looked like this, so that's also why a lot of times I only end up doing one. All right, your problems then are 1, 7, 9, 19 and 23. 11 through 14, I would say look at, okay? Not necessarily that you have to do them, but look at that. They give you a picture and they ask you to find the limit as x approaches 3 from the left, from the right, as x goes to infinity and x goes to negative infinity. It's kind of just a different application of what we did yesterday with the horizontal and vertical asymptotes and explaining what happens in each of those scenarios. You've got your the ones for vertical are 11 and 12, and then the horizontal are 13 and 14 in the sense of how they ask them. So, anyways, just look at those and make sure you could look at a graph and see it that way. And then tomorrow, if you're like not sure about it or you're confused or whatever, we can go over it tomorrow. Or if y'all finish early today, we can look at it today. But yeah.